Well, hello there everyone. Welcome to our webinar. Today we're going to tackle 5-ish common website issues, and we're going to show off how to effectively debug these issues with everyone's favorite web debugging proxy, and that is Fiddler, of course. As usual, before we really get started, I want to make sure if you're having any audio problems, make sure you connect to your computer audio, not your phone. If that doesn't work, try just restarting your GoToWebinar viewer and all should be okay. If that doesn't work, or if you want to watch the webinar again or share it with someone, you will be receiving a follow-up email with a link to the recording on YouTube. We'll also be sure to send out some links to some of the resources we cover today in that email. Now, if you have any questions at all during the webinar, I did want to remind you that you should definitely let us know. Just use that Q&A panel provided in your GoToWebinar viewer to ask away. I think it's over here or over here. I don't know which way the viewer is pointed. But if you're on a desktop browser, I think it is to your right. Now, we've got plenty of folks here to help answer your questions during the webinar. So let me get to introductions so you can put some names to voices today. And I'll start with myself, Rob Lauer. I am a Senior Manager of Developer Relations here at Progress. But far more importantly, is our Developer Engagement Manager, Jonathan Pereira. And finally, Sebastian Vitalitz, our Senior Developer Advocate, is here as well. So welcome, guys. I know everyone here is looking forward to your content today. Now be sure to follow us on Twitter at Telerik Fiddler. We do try our best to share the very latest information about Fiddler and the expanding Fiddler ecosystem on this channel. So a big part of our debugging story today revolves around Fiddler and using Fiddler to tackle these issues we regularly encounter. So what we'd like to do here is get a little more creative and actually use the new version of Fiddler, known as Fiddler Everywhere. Now, more on Fiddler Everywhere in just a minute. If you're new to Fiddler, or new to Fiddler Everywhere, don't worry, you're not alone. At its core, the original version of Fiddler is a powerful desktop tool. It allows you to quickly inspect, debug, mock, and save basically any network request and response. Now just think of, all the remote API requests your apps make these days. Fiddler can capture, report on, alter, and replicate all those requests. And Fiddler's been around for a while. The first version was released more than 15 years ago, if you can believe it. So if Fiddler is this, amazing network debugging proxy for any browser, any app, any process, or platform, what does it really mean in terms of actual use cases? Well, we can really start with the obvious, debugging web and network traffic on any device. It does also mean debugging of remote API calls. Even performance testing of your APIs is possible. Maybe analytics and monitoring, those things can all be handled by Fiddler, along with malware analysis and security testing. Now, that's a lot for one tool to bite off, but Fiddler does have some amazing capabilities baked in. Now, how these are actually accomplished with Fiddler is through a variety of features. You can directly inspect network traffic calls, both outgoing requests and incoming responses. You can create customized sets of rules that respond to certain request parameters. Say you want to alter a request for a specific URL and replace it with another call or a local file or whatever. That's all doable with the AUTORESPONDER. And related is this ability to mock requests. So as you're building out your app, and if you don't already have a functioning API in place, you can build up rules that will allow you to develop against a mocked up set of data, like a local JSON file, for instance. Additionally, you can compose API requests and inspect those responses, much like you might normally do in a tool like Postman. And you can visualize HTTP and HTTPS traffic to look at performance issues and identify bottlenecks in your app. All good, right? Well, the Fiddler UI is starting to get maybe a wee bit cluttered, a wee bit out of date. So a couple years ago, we knew that Fiddler needed a refresh. So we actively reached out to a lot of you and started having really meaningful conversations about, what you love about Fiddler. But even more so, what do you not like? What can we do better? And we learned a lot. We learned that the way you're using Fiddler is really different from how it was maybe intended to be used even 5 or, of course, like 10 years ago. And we learned that there are, some pain points we needed to address. We're of course dealing with 15 plus years of features and UI that makes it exceedingly difficult for new users to get onboarded. The platforms we used to develop on is changing as some of us transition maybe off of Windows and onto Mac or Linux. And the way we work with each other is dramatically different than what it was when Fiddler was first born all those years ago. So where did we go with these pain points? Well, we started by having one-on-one conversations with you, our users of Fiddler. And we worked to define what the exact problems are that we can solve. And of course, we learned right away that Fiddler needs a complete overhaul of its user experience. Gone are the days of the antiquated Windows UIs. No surprise, but you all aren't on Windows anymore. Many of us, of course, use macOS or Linux for app development. And finally, many of you are working in teams, and the way we really diagnose and share sensitive network logs is much different now than it was 10 or more years ago. So this all brings us to our solution. And that solution is the aforementioned Fiddler Everywhere. So Fiddler Everywhere is a completely new version of Fiddler, written using cross-platform technologies, yet sharing the same core codebase with Fiddler. So adding new cross-platform features is far easier, and migrating existing features from the old Fiddler is a snap as they are based on established functionality. It also has a completely revamped user experience. Yet before we were really ready to release this new Fiddler Everywhere to the world, we want to make sure we had a baseline set of features that you've all come to expect from the original Fiddler. That's why we improved upon a few key features from the old Fiddler, what I'll try to refer to as Fiddler Classic going forward. The first is, of course, the Traffic Inspector feature. Again, this allows you to view the details for all network traffic to and from your app. And again, the AUTORESPONDER, which lets you create and modify rules that can customize traffic to test a variety of scenarios. And the API Composer, which lets you see the results of API requests without having to use another tool. And back to point number 1 from our user interviews, that being an updated user experience, Fiddler Everywhere was built from the ground up with the modern developer in mind. The new UI is gorgeous and far easier to use than ever before. And point 2, Fiddler does work across Windows, macOS, and Linux platforms. All features are supported equally well across all operating systems. And point 3, team collaboration. Now let me briefly introduce you to the team collaboration features of Fiddler Everywhere. By using the team features, you can save captured traffic like you've been doing for years. You can highlight certain saved sessions, add comments to them, and securely share the log files and context with your teammates. Now they can open these log files in their copy of Fiddler Everywhere, and you can continue to collaborate from there. So the way this all works is very simple. I can click a button here to save one or more captured sessions, provide a name for that saved session. I optionally add some additional information or context to maybe prepare my colleague for what I'm sharing with them. I then click to share that saved session, and I can invite my colleagues to collaborate via a simple email invite. So this all allows us to securely view all the same session data within Fiddler Everywhere and without having to share potentially sensitive data or in an otherwise maybe an awkward or potentially even dangerous manner. So if you'd like to know more about the team collaboration features of Fiddler Everywhere, just head to bit.ly/fiddler-teams. And while Fiddler is best known as a desktop tool for debugging both desktop and web apps, I've got a little secret for you. You can pretty much inspect network traffic on any app or device that supports a network proxy. You can, of course, grab your copy of Fiddler Everywhere at telerik.com/fiddler and try it all for yourself. Okay, that's more than enough of an introduction to Fiddler and Fiddler Everywhere. Now I can stop talking at you and instead focus on the real experts here today. So first up, I'd like to invite Jonathan onto the stage to tackle the first of our many website issues. Jonathan, why don't you take it away?
Thank you, Rob. Hi everyone and welcome to this webinar today. Today we are going to be talking about debugging common website issues that you face. We'll see how we can identify these issues, which sometimes can be very difficult to spot. And then we'll also have a look on how you can debug these issues. And to do that, we are going to use Fiddler Everywhere, which is a tool loved by millions of developers globally. For the very few of you who are still wondering what Fiddler Everywhere is primarily a network debugging proxy, which is used to inspect, debug, mock, and share network requests and responses on any device which supports a proxy. So every request you make when you open a web page in any browser, be it on your desktop or mobile, Fiddler Everywhere can capture it, inspect it, and even modify it for you. The best part about Fiddler Everywhere is that it works with all web browsers, desktop apps, processes, and platforms. Some of the use cases of Fiddler Everywhere include debugging web, desktop, and mobile applications. Similarly, Fiddler Everywhere can also be used to debug APIs to test for authentication and HTTP status code. Fiddler Everywhere can also be used for performance testing to carry out load tests and even simulate bandwidth and latency tests. You can also use Fiddler Everywhere for analytics debugging when you need to verify the tag setup in Google Analytics or your other analytics engines. Similarly, you can also use Fiddler Everywhere in malware analysis to reverse engineer malware. And finally, Fiddler Everywhere is also used in security testing, where it is used to inspect and manage web sessions and even check for cross-site scripting vulnerabilities. In a bid to support all our developers using different platforms, Fiddler Everywhere is natively available on Windows, macOS, and Linux, and it supports all the browsers out there. So if you still haven't downloaded Fiddler Everywhere and want to give it a try, head over to the Telerik page to download Fiddler Everywhere. Coming back to the topic at hand, debugging the common website issues. Today we are going to talk about some of the issues that we see occur regularly and some of those which really make the lives of developers miserable. Just knowing how to find that issue, locate it, inspect it, can really simplify your life and make it happy. So the first one that we are going to be looking at is cataloging network requests. We all know that a website is made up of multiple requests which fetch the HTML, the CSS, the JavaScript, and the million other components that your website has. But sometimes it can be a huge pain to understand all the requests that a website issues. But with Fiddler Everywhere, you can filter out the request based on the criteria that you specify. And let's see how we can solve this problem using Fiddler Everywhere. For today's example, I'm going to use the Hashnode website to inspect some of the errors that are present on the page. And then using Fiddler Everywhere, I'm going to see how we can debug them. On the first glance of this website, it doesn't look like anything could possibly be wrong, because everything seems to be loading correctly. And that's the modern day problem that we have. With most of the libraries having backup options to help you render in case a particular library fails, it is very difficult to pinpoint what works and what doesn't work. And that's exactly where Fiddler Everywhere comes in. Now I'm going to open up Fiddler Everywhere and start inspecting this website in Fiddler Everywhere. Now, as you can see, Fiddler Everywhere has captured each and every network request that has come from the Hashnode website, along with the other hundreds of requests coming in from the different websites and applications open on my computer right now. Fiddler Everywhere by default shows you the type of file that every request brings. For example, this is an HTML file, whereas here we have a CSS, and these are a couple of JavaScript files used by Hashnode. And we know that this particular file is coming from Hashnode because the host is indicated as Hashnode. Now, one way to see all the files coming in from Hashnode itself would be to add a filter. And with Fiddler Everywhere, you can just put a filter on the host which says contains Hashnode. And once we hit the filter, only the requests coming in from Hashnode will be provided. The problem with this, however, is it shows the requests coming in only from the host of Hashnode. However, modern websites contain a lot of requests which use third-party servers, or for example, your CDN servers, or sometimes use third-party libraries which are hosted on their own servers, which means a couple of requests which Hashnode services would not be visible when I apply this filter. And for that, Fiddler Everywhere provides you this excellent option to help you see all the requests coming in from one particular website. But before that, I'm going to clear out this filter so that we can see all the requests. I'm going to click on the parent request and right click and go to select. And I'm going to select all the child requests coming in from this particular request. Now, as you can see, Fiddler Everywhere has selected a couple of requests which apparently have come when I loaded the Hashnode website. Now, as you can see, while most of them do come from the Hashnode host, a couple of them, for example, the Facebook JavaScript file, the talk.js, Hotjar, and a couple of other similar scripts have not come from the Hashnode server. Yet, Fiddler Everywhere has selected all of these. Now, I'm going to save these by clicking Save Selected Sessions. I'm going to give the session name Hashnode, and I'm going to click Save. Now, a new session has been saved. When I double click it, it will open in a new tab for me. Now, this includes all the recorded sessions from Hashnode. And these are all the requests that went out when I hit the hashnode.com website URL. Again, I can quickly identify how many HTML files are there, how many CSS files are there, and all the JavaScript files that are present within this session. This makes it really simple for you to understand the various requests going out and coming in every time a website is loaded. This becomes really important if you want to track down some malicious requests that you might think are present when a website is being loaded. Now that we saw how we can catalog all the network requests without having to hit the filter option on Fiddler Everywhere, let's go on to see how we can identify website errors. Now, website errors could be caused due to multiple things. It could be a 4xx error, which is caused due to a client-side problem, or it could be a 5xx error which is caused due to some kind of communication problem with the server. We are going to see how we can identify these problems using Fiddler Everywhere. Once again, let me remind you, when we opened up Hashnode, it seemed like everything is working fine. But if we go to Fiddler Everywhere and see all the traffic that has been captured, you will notice a 404 error right here. The request is indicated in red, showing that it is an error. And if you click on that particular request in the traffic inspectors, you can see that that particular response was not found, which means it's a 404 error. So even though the website seemed to be working fine, Fiddler Everywhere quickly helps you to identify errors which might not be clearly visible in the UI, using just the status code of that particular request. This method can be used to identify not just 404 errors, but all 4xx errors as well as 5xx errors. And this really makes it simple to quickly identify and pinpoint that particular error. Now let's see how we can solve this problem. So again, when I come to my inspector, in the request headers, I can see the get request hitting an URL which seems to be wrongly typed. If I'm not mistaken, what the intended action was supposed to fetch this particular URL, which is a Google APIs for fonts. Now let's see if that's indeed the case. And to do that, I'm going to copy this URL, and then using autoresponder, I'm going to apply a rule which would redirect it to this particular URL every time this particular request was made. The autoresponder allows you to create and mock rules so that you can provide responses without actually contacting the server. A couple of options that the autoresponder provides you include resetting the connection, changing the headers, as well as redirecting. But in this case, all I'm going to do is paste that particular URL. And I'm going to save this rule. Make sure to turn on the autoresponder by toggling the button next to it. So let me again clear all of this previous history and let me reload the session and see how the website reacts now. So if you see, this is the exact CSS file that we resolved, and now it seems to be working perfectly fine. And if you notice, the 404 error is now gone. So we use Fiddler Everywhere not only to inspect and identify a 404 error, but also to quickly debug it. Now, if I had to make the same change on the server, this problem would be permanently solved. But I use my autoresponder to mock the response and make sure that it really is solved locally. So that is how you can use Fiddler Everywhere to identify various website related errors, some of which may not be directly visible in the UI of the website, but still do exist. Now coming to the third one, and this one is sometimes a little tricky for developers because we constantly keep hearing the phrase, "it did work on my system." And that exactly is one of the major problems that we face while testing websites. How do you simulate an error or a problem that a user is facing on his environment when it's not happening on mine? And that is another beautiful feature that Fiddler Everywhere brings to the table. With Fiddler Everywhere, you can mock issues and errors in such a way that you can literally simulate your user's environment. And we are going to do this again using the autoresponder feature. In my Hashnode website, if I wanted to see what would happen if my CSS took a little longer than usual to load, then I can use Fiddler Everywhere to simulate this potential issue and know the exact scenario that would happen. So I'm going to locate any CSS file that I find, for example this one, and I'm going to add a new rule for it using autoresponder. Now in this rule, what I'm going to do is I'm going to add an action that says every time this CSS file is being loaded, I want to set a delay of 10,000 milliseconds, which is approximately 10 seconds. And I'm going to save this, and it's time to reload this session and see what happens. So when I reload the session, you can see that the website is still waiting, and then after 10 seconds it loads. Now we saw the changes that took place once the CSS file loaded. For example, all of these icons and text blocks were resized and fell in place as expected. And that is how you can use Fiddler Everywhere's autoresponder feature to mock potential issues that can crop up within your website and then identify them before they actually occur. And this helps you get a head start in fixing them. So now I hand it over to Sebastian, who will talk more about some of the commonly faced issues, and he'll show you some very cool stuff too. Over to you, Sebastian.
Thank you, Jonathan. This was pretty cool, and I really enjoyed that. And it looks like we learn every day, and there's always some cool things that we can do to improve our development processes. So, hello everyone. My name is Sebastian Vitalec. I'm a senior developer advocate at Progress. If you want to, you could follow me on Twitter at Sebawita. So I want to continue on the vein of debugging common website issues, and I have a couple of other hints and examples that we could probably try to do more of in the future so that our development gets better. So one issue that we could actually look at is how do you handle expired tokens? Because let's face it, sometimes tokens expire and your applications should be prepared for that. And in case you're new to the topic, here is a quick overview of how authentication with tokens works. So often your site will make a request to log in with the user information to an external service, and that service will validate whether the user and password is correct, and you will return the token for that request. And once you have that token, then you could make all sort of requests, like you could get data and then you have to pass in the token. And when the server is happy with this, it will go and fetch the data and send it back to your application. And if we look at the token, most of the time you have these two pieces of information. One, you have the access token itself. So this is the code that you have to send every time you make a request, but also tokens will have an expiry date and time. It basically means that sometimes when you wait too long, that token can expire. So, and when a token expires and you issue a request to the server with an old token, you should get a 401 unauthorized response. So what do we do at this moment? Do we panic? Do we cry? Do we run around? Well, we should all keep calm and just generate a new token. So the whole idea is that when we are getting an error, when we're trying to request some data from the server and we are getting the 401, basically we should just request from the server to get a new token and then reissue the same request again. And this is basically how we should solve this kind of problems. But then the problem comes to it, how do we even test that? When, well, let's face it, a default token expiry time is actually 1 hour. So if I'm working on an application and I have to test the same thing at least like 4 or 5 times or maybe more as I'm trying different types of solutions, waiting for a token to expire can be very, very slow. And you might end up testing something that should take 20 minutes, half an hour. It could take you hours or days. But do not despair. There is a solution that I want to show you that is really, really cool. And like the kitty says it, you should use an autoresponder to mock a 401 scenario. And the whole idea is that you basically can tell Fiddler Autoresponder to wait for a request that comes with a specific token value in the header. And then when the autoresponder sees that, it will basically override and then respond with 401. So let me show you how this is done. So here's my sample application. And here is my sample application that I want to show you all sort of things that we could do today. And on the right-hand side, we have Chrome DevTools going so that you could actually see some of the console logs that are planted just in case. And when I log in, we will get a user information. So like we'll get like the whole token info. So you have the actual access token and the expiry date. Which will basically happen in 2 hours from now. And then we get some auto-generated score. So every time I actually reload the score, we actually get different results with some kind of predictions of who would win if that was the score at this given time. And so we could do a few things from here. So what we can do is I can enable live traffic. And let's say reload scores again. And we get a new set of scores this time. And just to make it a bit more tidy, let's add demo APIs so that we only see the ones that we want. And just by seeing this request, we could see that this was the request that the last one that happened. And what I can do here is I can add a new rule. Okay, so for now, the rule says whenever somebody requests data from exactly the same endpoint, if I enable autoresponder, we should be getting the same data, and you can see it's like the same, we're getting the same scores over and over again. And I can even change some of the scores. So let's say Liverpool home goals 5. That's not even ambitious. That's basically how reality works. And now Liverpool is winning 5-0. So you could kind of like force these scores to appear as we wish them to be. But what we really want to do is do something like this. We want this request to actually fail. Well, and we want it to fail with a 401. So what we kind of need to do is change one thing. So we want to only match this when the header, and we are not going to do accept equals HTML, but instead we'll do authorization equals, and that's our token. Okay, so now let's put just 12 in here to see that this is actually working. So we reload scores. And that didn't work because I had a little typo. So it's authorization. All right, let's try one more time. And yes, whenever we get the same token, we will get 12.0. So this is not exactly what we wanted to do just yet. What we really want to do is change the actual response to say token expired, and we can save that. And at this point, we can see what will happen when that token expires, when we reload the results, and can my application even handle this scenario? And actually, it is not prepared to handle it. What a surprise. So we are getting 401, the whole thing falls apart, and this is only because the developer never actually waited for that 1 hour for the token to expire. So let's have a look and let's try to fix the issue. Okay, so what do we need to do? So the application is written in Angular, and with RxJS, we could do all sort of really cool things. So we have this get games HTTP request, which basically calls this slash like demo APIs live score slash live. But what we have to kind of do is, if this fails, we want to kind of say, hey, I want to issue the new token again, which is basically done by calling login HTTP. So what we need to do is basically in here, we want to catch an error. We called this get games HTTP once, it fails, but this catches the error. So as a result, we say, okay, I'm going to just call the login again with the same user details again, display some message, and then one more time attempt the get games HTTP request. And when that works, we should be good. Okay, so automatically we are back at the login page, so we will get a new token, but we are logging in again. So let me get this token from here, and I am going to go one more time to Fiddler Everywhere, paste our new token, save it. So I should expect it to fail once when I reload. It fails, but then we are getting a new token and we are getting the refreshing the token message, and we can keep going and keep refreshing. And just like that, we were able to test that my application wasn't prepared for expired tokens. Then I was able to update the solution and in a very easy way retest it again and again. And instead of waiting for an hour, I could do it just in space of like 30 seconds. How cool is that? Okay, so that was one issue we have off our list. Another thing is, and this is actually a category of really wide range of issues, fixing random errors. How do you go about it if you can't put your finger on it? Some issues are so inconsistent that it is almost impossible to fix an error if you can't debug it, if you can't see what is happening in the code. And then this is getting every time more and more frustrating. And very often it's just a guessing game. Maybe sometimes it could be even something that happens just on a live server, but it works directly on your machine. It's just hard to know. And so what can we do about it? So when there is an issue where each time you are getting different data from, let's say, an HTTP request, what you could do is capture that live traffic and then keep going until your code breaks, until you get that issue. And then you could basically use the autoresponder to keep replying with the same problematic response. And then you can go on and debug it. And you can debug it reliably because you know every time you are going to make that call, you will get that issue. And like, we should all listen to the doggo because doggo knows his stuff. So let's go back to the project, and I have a quick refresh in here. So starting again, we can log in. And what I will do, I know that every now and then this application, for some reason, when I'm reloading the scores, it fails. So I can keep reloading and everything. Ooh, there is an error, and it just says invalid status soon. and it happened in the predictor.js. So it kind of happens here, but I want to be able to now stop here and kind of see what was happening that actually broke the code. And funny enough, if I reload the score, I will get here, and let's say I can step over. Is it a valid number? Apparently it is. So the error just went away, and I have no way of actually verifying that something went wrong. So what can we do? We could go to Fiddler Everywhere, and then basically we know that this is the last response that worked. So it's probably this one that caused us some issues. And we could see our records in here. I think it looks okay. So what I can do is add a new rule, and let's disable this one. So we could basically get the same response over and over again. So if I can go back to my browser, I can reload, and we could see status 60, 90 plus 2, 46, 15, looks good. Ooh, there is one that says soon, and my code is actually not prepared for that. So if I step over, this is not a valid number, and we are getting an error. So that's probably because if we have a look here, yes, one of the records suddenly returns status soon, while I think previously we didn't have that record coming up. So now we could reliably go back and try to resolve the issue. So interesting enough, the predictor.js doesn't even come from my Angular project. This was like an external file. So fixing it won't even work directly in my Angular application, but I have managed to get a copy of this file. So what we can do is basically try to fix it here. So the idea was that we had a status that was soon, that was breaking. So why don't I just replicate and say, if it's soon, just return 0, and that should probably do the trick. Okay, so in Fiddler Everywhere, what we can do is say, hey, we're looking for a file that ends with .js. So we can find now our predictor, and we will add a new rule. And in this rule, we could basically see that we are getting a file back. It is encoded with BR. I think the team is working on making that actually visible. But instead of manually crafting response, I can choose a save file. So this is my predictor file, and I will basically return it, and then basically force the returning of that file every time there is a request to it. And to actually make it to show you that this is even happening, at the beginning, I'm just going to do an annoying alert saying hi, just to show you that this does work. Okay, so let's reload my application. And after reloading, you see we are getting the hi response. And then I can press login. And this time, let's actually put a breakpoint over here. We could get 90 plus 2, 46, 15. And this time we are getting soon. So returning 0, and nothing breaks. And that's it. But the last thing I want to show you is that the trick with replacing the JavaScript file can also be done on live production servers. So sometimes you are working on a fix and you think that this could work, but maybe the whole scenario, the whole application that you're working on is really complex, and you just need to double check that it's working in production before you even push that change. So what we can do is, again, we could use the autoresponder to return the file replacement and test it with a production application. So let me show you how this is done. So I have the same website published under demo APIs, Footy Live. And you could see like I'm loading it and I'm already getting the high coming up. So why is that happening? This is because we still have this code that whenever somebody requests the predictor.js, we should respond that. You see now, if I'm going to reload the page, there is no message. So on a published application, you could see the app breaks, right? If I then go back and then re-enable the predictor.js, and let's try again, load it, saying hi, and we probably don't even need those breakpoints. So let's just let it run, and the application works. So we were able to do that hot patching on a deployed application that is not even on my computer, but it's somewhere else, and it works really, really nicely. And if you ever need to do something like this, then Fiddler can be your friend. And that's it from me. Thank you for listening. I hope that you enjoyed the tips and tricks that we provided you so far. And I'll pass the mic over to Rob. Over to you, Rob.
Awesome. Thank you, Jonathan, and thank you, Sebastian. Great work as usual. Now, before we wind down today, you do get me again, and I do have the proverbial one more thing before we close, and that has to do with the reality that, really remotely debugging issues you receive from customers is not easy. This is no surprise to any of us, I'm sure. You're relying on both technical and non-technical users to really accurately convey what can be a very detailed problem with very little context. And oftentimes, no technical logs or information to really help you out. And to really diagnose these issues, frankly, it's not easy for customers to even submit their network log files, especially for those non-technical users. They're worried about privacy, they're worried about security of their data. Support teams, they waste a ton of time with back and forth between them and customers. Just collecting log files is like pulling teeth, and there are internal compliance and security issues they need to work around. And finally, developers, they don't have much to go on due to a lack of information and real inability to replicate issues with the info that they have on hand. I'm excited to say in the coming weeks, you're going to have a chance to experience our way of solving this problem, and that is with a brand new product called Fiddler Jam. And at the risk of reading text off a slide, I can tell you now that Fiddler Jam is a solution for support and dev teams to help them troubleshoot issues in a fast, easy, and secure manner. Well, what does this mean? Let me play my very quick demo of the Fiddler Jam workflow so you can see for yourself how we will help solve this problem. For this demo, I'm going to use a simple to-do web app. So wearing my end user hat, I'm going to type in buy milk and click submit. And right away I get an error which notifies me that the item cannot be added. Well, that's no good. After consulting with the support team, they've directed me to use the Fiddler Jam Chrome extension to record network logs while reproducing the issue. Then I can securely send them the logs for further analysis. Let's see how this is done. Now I already have the Chrome extension installed, so I open it by clicking on the icon. The UI is pretty simple, letting non-technical users record and submit issues with a minimal interface. So I can click to start capturing log files, reproduce the issue in my browser, then stop capture to obviously stop capture of the logs. There's also an option to capture screenshots on clicks, so every time I click my mouse, a screenshot will be saved along with the log files. So let's turn that on and start recording. Now that recording is started, I'm going to want to try and reproduce that issue. Let's add buy milk again, and this time it works. Well, it's interesting. Let's try buy bread instead. Now we get the error. Now since that error was recorded, let's stop the capture and share these log files with the support team. Once I click on stop, I'll have the option to view the log details captured. A more technical end user may want to see this. But let's hide those details for now and share the captured sessions. Next, we have this option to set password protection. This will secure and encrypt our log files with the supplied password. So let's enter a password, my email address, and a description to save the logs. Now I can save everything in the cloud and submit the saved logs to the support team. Since I added a password, the logs will be encrypted and everything will be securely saved in cloud storage. And as soon as that upload is complete, a link will be generated and can be manually shared with the support team. Now, switching hats and acting as a support person, I can open the provided URL in my browser, which will take me to the web dashboard. Let's enter the password from the end user here. And once the password is entered, the log file is then decrypted and displayed in the browser. Now, the log file contains all the requests and responses that were captured while the end user was replicating that issue. On the left of our view, we see all those request URLs, and on the right, we see the request details and the response details for individual requests. On this one, we can see where a to-do item endpoint failed. I can click on the item to see the details. In the response headers, I'm seeing an internal server error. Well, that likely caused the initial problem. I can also see the screenshot of exactly when that error occurred, giving me even more context and a visual representation of the state of the application at that time. Now I can also add comments to the requests to add additional context for the development team, who will next be looking at the issue. In this case, I'll add a comment on the issue that failed, describing it in some more detail. Now that the support team is done and has triaged the issue, I can then move on to the dev team for further analysis. Again, switching my hats, as the developer team, I can use the web portal to view some details about the request, including the screenshots, just like the support team did. Let's open the failed request again and look at any comments that were added. Now, most importantly, I can then open the captured logs in Fiddler Everywhere to do further analysis, such as replaying the captured session to test the scenario in action. I can also test the behavior of the remote API with the exact parameters used when that request failed. I can also create auto-responding rules to mock the responses and simulate any issues the customer may have experienced. So in the last few minutes, we covered all three user scenarios, from the end user's experience of capturing the details of the error through to the support team and how they quickly triaged the issue, finally to the developer and how we viewed the comments and loaded the sessions directly into Fiddler Everywhere to further diagnose and debug. Alright, if your curiosity is piqued, you can learn a little more about Fiddler Jam and sign up for our pilot program at telerik.com/fiddler-jam. And that's it. Thank you all so much for attending. For next steps, I recommend you download Fiddler Everywhere today at telerik.com/fiddler and take it for a spin. And take a look at what's coming from the Fiddler family in remote network debugging with Fiddler Jam. Sign up for the pilot program right now at telerik.com/fiddler-jam. So that is all from us. Thanks again and have a great rest of your day.